Okay, if you missed class today or you wanted to review some of the content, here it is. We talked about trig derivatives or the derivatives of trig functions. So this d dx in here just means to take the derivative of. So the derivative of sine x equals cosine and kind of down the list. This is our reference sheet. We're going to kind of live by this. Anytime we are talking about the derivative of trig functions, we're going to use this to kind of see what turns into what. So as we can see, if we take the derivative of all these functions, we'll get the resulting functions. And so let's practice. For each of the following, we're going to find f prime of x. We're going to find the derivative of these functions. We see a -3 sine x. So we have a coefficient with a function sine x. I'm going to treat those kind of separate. In fact, one of our rules of derivatives is that we can actually pull out that function, or sorry, that coefficient, and we can take the derivative of the resulting function separately. So let's actually figure out, what does sine of x turn into? So I'm going to highlight this, and I'm actually going to look, first of all, what am I taking the derivative of? Just sine. So let's look up here. What is the derivative of sine? And we can see that the derivative of sine is cosine. So this sine is going to turn into cosine right there. And let me write that in a different color. And notice how I used parentheses to kind of show that I was separating those two things, but that really just means multiplication. So we can put those back together again. And that -3 times cosine, just think of that -3 as being the coefficient. 3 cos x. Done. There's my derivative. Another problem, it gets a little bit more complicated when we introduce several more terms. So in this one, we have -2 cosine x. We're going to concentrate just on that to start. So we're going to think of what is the derivative of -2 cos x. So first, like the last problem, we're going to keep that -2 as a coefficient out front. And then we're going to take the derivative of just the cosine function. And when I take the derivative of just cosine, let's come on up here, there's my cosine function. That's going to turn into sine, or sorry, negative sine. So when I do the derivative of cosine x, that's going to turn into negative sine x. All right, I'm going to leave that with parentheses right now to kind of show that separation, and I'm going to put those back together again in a moment. But now we're also going to take the derivative of tangent. And so let's see, what is the derivative of tangent of x? Let's use our reference sheet again, and we can find tangent right here, and the derivative of tangent is secant squared. So that tangent of x is going to turn into secant squared of x. And once again, I'm just basically figuring out what I'm taking the derivative of, and then what that is going to turn into. And that's what I'm going to replace in my function. So this would be my answer, but I'm just going to clean this up because we know -2 times negative sine. Think about that as having a -1 out front. -2 times -1 would be a +2 sine x plus that secant squared x. There's my derivative. And then lastly, this fourth one is combining a couple of different skills. And I wanted to do this one separately because this -4 is not a coefficient. This -4 is its own term. The coefficient on this cosecant is really like a -1 here, right? So we have two different things that I need to take the derivative of, -4 and negative cosine or cosecant. So let's just remember, what is the derivative of -4? Well, -4 is a constant, not a coefficient, but like a whole number, and that the derivative of any constant term is always 0. I'm going to put that 0 in there for now. And then I'm going to take the derivative of negative cosecant. So let's look up at what we have up here. Now, I don't have the derivative of negative cosecant, but I know I have the derivative of cosecant. So what we're going to do is we're just going to copy down this negative sign and think of that as our coefficient of -1. And then separately, we're going to take the derivative of cosecant, which turns into this whole thing here, negative cosecant x cotangent x. Let me just erase this one parenthesis here, and let's write that in. Great. And now we can see here that we have 0 minus a negative, and I know that there's a bunch of letters in here, and it's kind of hard to figure out which does that negative go with. The negative goes with everything, right? So think of that cosecant x, cotangent x as being one clump, one term, all stuck together, making that entire thing negative. So we have 0 minus negative, that whole thing. And we can see if we minus a negative there, that's going to turn into a positive. We no longer need the 0. So this is just going to turn into cosecant x, cotangent x. So I'm thinking of these as kind of two separate steps. Three separate steps. One, identifying what my original function is, and then identifying what do I need to plug in, right? And I'm using those parentheses then to kind of show that I plugged it in. Sine turns into cosine, cosine turns into negative sine, tan into secant squared, cosecant into negative cosecant, cotangent. And then I'm really finishing off and just making sure, are there any, are there two negatives that will cancel, so to speak, into a positive, right? Or will things stay negative in those situations, right? And so that's that, just making sure that you're substituting in the right functions. Go to that Desmos, try a few, and email me when you finish.